Welcome to today's webcast. This call is being recorded. And now to begin the program, I'd like to introduce Tracy Cook. Please go ahead.
Thank you so much. Hello, everyone, and welcome to today's webcast, StarWind Storage Appliance, High Performance and Resiliency, sponsored by StarWind. I'm Tracy Cook with Redmond Magazine, and I'd like to thank you all for joining us. Before we begin, let me take care of a few housekeeping details. Please feel free to type your questions into the Ask a Question box on the console at any time during the presentation. We'll address as many of your questions as we can during the live event. This webcast is being recorded and will be archived for future viewing, and we'll send you an email when the replay is available, and that should be in approximately 24 to 48 hours. And you can access the replay using the same link you used today. And now I'd like to introduce our speaker. We have Olis Boris, Director of Support Department from StarWind, joining us today. Olis, please take it away.
Yep. Hello, ladies and gentlemen. So this webinar is going to be about StarWind Storage Appliance. You might have noticed that because of what you see on your screen, and I'm going to be talking about StarWind Storage Appliance. But before we talk about the appliance itself, I would like to give you a little bit more information about our company, what it was doing, and how we moved towards hardware solution that we are going to talk about during this webinar. So this is pretty much where we started and where we ended up. The company was founded in 2003, and what we have made back in the days is we made first iSCSI target implementation like quicker than anyone else. We just did iSCSI target, and we were doing it for quite a while, as you can see. Then in 2009 we had a spin-off and focused our company on the storage, and then it took some time to develop our software like StarWind Virtual SAN, and then we became first hybrid converged storage solution for Hyper-V, later on for iSCSI as well, and pretty much at 2011 this is where StarWind Virtual Sun version 6 was released. And after that we've made HA storage, other words software defined storage, and then we were basically developing, updating, and moving forward with it until 2015. In 2015 we realized that doing just the software part of the whole system is not good enough, because loads of people have many questions about what hardware do we use in this or that situation, what hypervisor do we use, and so on and so on. So basically people were using our software and building like do-it-yourself solution based on our recommendations, and then we decided that it is going to be much better if we do a solution that is built according to our recommendations and that has software that is fully tested and fully fits StarWind and customer needs as well. And we released HCA, it's our hyper-converged appliance. Then in 2016 we released second generation of HCA, and we added storage appliance as well. So the differences between hybrid converged appliance and storage appliance is that hybrid converged appliance is aimed towards SMB, towards people that really do not have anything and are building virtualized infrastructure from the scratch. So people that would like to buy a solution which is basically plug and play, so they have received the boxes, unboxed it, wired up, and they can start running their production. Where storage appliance is a solution for people who already do have virtualized infrastructure and they just need storage. So they can go ahead, open up the storage box, storage appliance box, wire it up to your existing virtualized infrastructure, and have additional storage in it with StarWind Virtual SAN on it in order to share it via iSCSI. Recently in 2016 we included the support of ISER, and then it's an RDMA extension for VMware, also NVMf, and then we have hardware cloud gateway. So that's pretty much what we've been doing and what we are doing right now. Let's take a closer look at StarWind storage appliance and customers that would want this storage appliance, and what is our proposition and what is so special that we have in it. So the first problem that customer faces when they have a need to grow their storage is that they would usually, so small businesses, and we are a company that is aimed towards small businesses, remote and branch offices. They usually do not expect any data growth or performance growth, and then in case all of a sudden your product and your small business becomes growing very, very fast because you're doing something very cool and people go ahead and buy what you are doing, so your services, products, whatever, you really need to grow your virtualized infrastructure, and you need to grow it storage-wise. Here is where our hyper-converged appliance comes in, as it is easy, like it's just plug and play. So we do support all the available protocols, and it will fit your virtualized infrastructure, the one you did build when your business started. So the benefits of it is that it is very fast, it is fully redundant, fault tolerant, and our initial product, StarWind Virtual SAN, did highly available shared storage. So this is what this appliance does as well. It can easily integrate, as I just said, into any setup, both converged and hyper-converged, because of the protocols that we use. So now let's move on to what is in that box. In that box, we have hardware from Dell, we have solid-state drives from Intel, and then the network part is from Mellanox. Software can be software is Microsoft, as we are running Virtual SAN on top of that, and our StarWind Virtual SAN is a Windows native application. And how we came up with this year, as we have been testing various hardware and software components for a very, very, very long time for reliability and performance, and while keeping the cost low. And we've decided that a server based on Dell PowerEdge OEM hardware, and networking from our partners Mellanox, and then the storage from our Intel partners would fit us performance-wise, reliability-wise, and then cost-wise. Basically, I guess this is it in terms of what is in the box. Let's move on to the modules that we have available for the storage appliance, and what is the difference between them. There are really like two modules, but in the second part there are two variations of modules. But right now let's talk about our first model, which is 1H. What it has a so this is a hybrid storage array that will fit small and that is for small and medium volume size for secondary data, and it is capable of holding up to 44 terabytes. The only downside of this model comparing to our other models is that it is a single chassis array that provides pretty good performance within the typical HDD-based solution, and dual controllers inside this box provide fast failover and guaranteed high availability. So I would say that typical use cases for this solution include secondary data and virtualization storage, medical records, and potentially primary backup storage with low RPO, RTO requirements, or like Veeam likes to say, RPTO. Then in our other models, so there are two other models that are called 2H and 2AF. So 2H is the same exact storage array as the 1H, but it has a hybrid storage array with flexible configurations for small or large volumes of primary data, where the previous model would do the same thing for the secondary data. And the great benefit of it is that it has dual chassis array that will provide you with high performance, low latency for data processing, for low latency data processing for all of your applications. Then redundant disk set can be designed to provide you with starting at 4 terabytes, just like in the previous solution, and will fit up to 500 terabytes, so actually half a petabyte. And I mean, that's pretty much it. It does everything the same as previous one, but this one is a hybrid storage array, and it has dual chassis array. And then the most interesting one for myself is the 2AF model, which is an all-flash storage array with flexible configuration for, again, small to large volumes of primary hot data. It is primary and hot because you have from 4 to 500 terabytes of flash storage. It is also a dual chassis array with high performance across the entire storage capacity for most demanding applications, for example, like databases, big data, and you can use it also as a primary virtualization storage. This is pretty much it in terms of hardware and capacity. Of course, the CPU and the RAM will change from model to model in order to fit the performance and the performance that the drives in this model would provide you with. But as this is not aimed to run any virtual infrastructure on the host itself, we do not say about like its RAM or CPU over here, as this is a storage appliance. We are talking about the storage. So let's move on to other components that are, I mean, not to other components, but to things that are inside this box, feature and software-wise. So it has StarWind Virtual SAN, like I said before, and StarWind Virtual SAN is the software that we've been doing for a very long time, and we think that it is the best thing that you can put into this storage appliance based on the configurations that we provide and the configurations that we would use. So the use case you can see on your screen right now, this is a diagram of what you will have built, what you will build if going with storage appliance. So the top layer of it, you have two nodes. Those have two NICs. Those can be like one port NICs or dual port NICs, doesn't matter. So the top part of this diagram is your virtualized infrastructure that you had before, and then when you need an extension, storage extension, or you just need the storage. I mean, previously you've been running all your virtualized infrastructure directly on servers. You didn't think about redundancy. Your business was pretty small, and then in case either of the application will go down, you wouldn't really care much, and because that wouldn't like lose your company any money, so you were fine about it. You would just wait for a couple of hours, wait until this application comes back online, and simply continue to work. But when your business starts growing extremely fast, you first need a lot of storage, and then you come up with things like, hey, if I'll have my application go down for some time, I'm guaranteed to lose like X amount of money, and I don't want that happening, so I'm looking for a solution that will make my production redundant. And this is what you can do with StarWind Storage Appliance, is you will take two boxes, and those boxes will have StarWind Virtual SAN installed on it. And then what StarWind Virtual SAN will do with the storage is it will have one box with all the storage in it. It will you install, so it actually will be installed for you. So you'll have StarWind installed on both boxes. StarWind will take storage from the first box, will take storage from the second box. It will synchronously replicate those between two nodes, and then via iSCSI, SMB, NFS, RDMA extensions, basically any protocol with any protocol, share it to your existing production. This way your existing production would get a highly available redundant storage, and in case one of the storage node or one of the compute nodes will go offline, your virtual machines will continue to run, as well as the storage. So this is pretty much why we put StarWind Virtual SAN in this in our solution, and what exactly it would do inside that solution, and how exactly it will help your production to work better and be redundant. So next, in our next slides, we are going to be talking about features and basically features that we do have in our storage appliances, and I will briefly explain why exactly those might be useful for you and might not, as in our software we have a lot of features, and as we all know, different features and different solutions as well, and so depending on your scenario and your need, your business and what you're looking for, you will use one or the other feature. So this one I actually would use for pretty much any business that I would run, as this is a disaster recovery option that we have in our appliances available. What StarWind Storage Appliance can do out of the box is it can do a replication to Azure, and in case something happens to my main office, to the facility where my servers are and where I am located, so in case a tornado will break my office, in case my servers will burn on fire or something really bad happens, I will always have a full copy of my data in the cloud, and I'll be able to recover from it. I think that's a very good and very good thing to do for any business you have, because you really do not want to lose years of your work because of, I don't know, because of natural disaster or a sysadmin that would delete your data. There was actually a great article about losing all the data on SpiceWorks recently, where one sysadmin, because of his mistake, had lost all the data, and basically they had closed the company because of that. So moving on to the next slide, here we are looking at our scaling options. So StarWind Virtual SAN has scale up and scale out available. What is a scale up? You do scale up by adding individual disk flash modules, JBODs, anything that you can physically add to one box and make the storage bigger, the CPU better, the RAM faster, or increase the amount of it. That will be called a scale up. And then as long as you have space inside your box, you are able to do that. But what happens in case you run out of that space, you'll have to scale out. So you can easily scale out with StarWind. In case you have our solution already, you have those 2 nodes, and you have HA, and everything is going well, and then your data amount of your data keeps growing and growing and growing, and you face a situation where there's not enough space even after getting a storage appliance. You then either get additional storage appliance or just purchase drives and put into your existing storage appliance. But we're looking at this if we do not have any space available in our existing systems, so we'll just go and get another storage appliance node that will be simply added into the storage cluster within 3 to 5 clicks, and that also will not be done by you, but will be done by StarWind support engineers, and you will have more storage. That's really easy and straightforward, so I don't see any sense in talking too much about this. So let's go to the next feature that is much more interesting than the previous one. So RDMA, iSCSI, ISER. So what is ISER? ISER stands for iSCSI extensions for RDMA, and RDMA is a remote direct memory access. Basically, that is an extension of the data transfer model of iSCSI, a storage networking standard for TCP/IP. It uses iSCSI components while taking the advantage of RDMA protocol. This link protocol can also be either Ethernet or InfiniBand, and supports speeds of 10, 40, 56, and 100 gigabits per second. The main advantage of ISER is that it uses the RDMA protocol suite to supply higher bandwidth for block storage transfers, which are called zero-time copy behavior. To that, in fact, it eliminates the TCP/IP processing overhead while preserving the compatibility with iSCSI protocol. In addition to that, it has much lower latency and CPU utilization, which actually, while still enjoying the stability and benefits that we are all used to in iSCSI protocol, like security, and high availability, and other cool things about it. So this is pretty much everything about RDMA, and I think it's a very, very, very cool thing. The only thing is that, unfortunately, this is a extremely new feature, and it wasn't much. There was no really a lot of time for people to use it and test it in production. Therefore, many of them think it is not production ready yet. I honestly did test ISER, and it felt pretty good, and I did see like real latency. I did see real latency benefits and CPU utilization savings. So that's it about ISER, and let's move on to the other features we have. So converged and compute and storage separated. This is one of the features that we have always had in actually all of the products that we do. So with pretty much any of our products, you can both do converged and hyper converged, and that's, I think, is a great benefit, as if you are doing converged, you save money on the long-term run, and then if you do hyper-converged, you save on the investments in the short term, but in long term you pay a bit more. Then depending on, again, your needs, growth plans, and so on, you choose either one or the other path. Another feature is that for all our solutions, we've been trying to use commodity hardware that you can pretty much find in any regular PC shop. This way, again, it's easy to find, it's easy to buy, and it does not cost much. It is not proprietary. It is not something you cannot easily get. So this was our goal while building our appliance solutions, and we made it. So the next slide that we have here is fault tolerance and high availability, and then unified storage protocol. Talking about fault tolerance and high availability. So with our StarWind Virtual SAN, what we basically do is we have available storage pool in one box and then available storage pool in the other box. And what we do with our software while creating a device, you're basically creating an image file, and this image is placed, for example, if talking from the first node perspective, this image file is placed inside the storage that is presented to the OS, and it is presented to the OS via RAID controller. So we have some available storage, and we put an image file in that storage. And for example, we have a 4 terabyte image file in there. What we do is we replicate this 4 terabyte image file to the same exact storage pool that we have on the second side. This way we have two identical image files in both nodes. And this image file will be called HA image. And let me explain you why. It will be called HA image because while running through the replication wizard, you will select the synchronization channel for it, and through that channel, all the data that will come in to the image file on the first node or to the image file on the second node will be synchronously replicated between those. This way, you have a device that is shared between two hosts and is redundant as it is active-active. Then what you will do is via any protocol pretty much, you share the storage to your production, and you have multiple sessions running to host 1 and multiple sessions running to host 2. What your production is seeing is it's seeing a device that has, for example, let's say 4 sessions. So your production will have access to your storage via 4 sessions, and then in case if one or the other node fails, what will happen is basically 2 sessions will disappear and your device will stay online just like it was before, and your production will see no difference at all. This device will just be there as it was, despite the fact that one of your nodes simply was turned off. This is how we do our high availability, and I think it's cool that you can turn off a node and nothing will happen. So unified storage, this is what I've been talking about for quite a bit in previous slides. So basically, again, we do support every protocol that we know about. We support iSCSI, we support NFS, we support SMB, we support NVMf and ISER, and they all work great. Let's go to the other features. So here we have optimized cache engine. So for those devices that I've been talking about previously when we were talking about high availability and fault tolerance, so optimized cache engine. For those devices, you can configure both L1 and L2 caching. And what is L1 and L2 caching? So L1 caching is a cache that we put in random access memory, and we can configure it for a device to be in write-through or write-back mode. Write-back mode will boost read and write performance. Write-through mode will boost only reads. So most of the vendors would not recommend configuring DRAM cache in write-back mode, as in case of a node failure, all the information that was cached in DRAM will simply be wiped out, because as we all know, random access memory does not keep the information when the node is turned off. So how StarWind fixes that issue, and why do we recommend configuring it in write-back? The logic that we are using to replicate these 2 image files between node 1 and node 2, so this logic is a synchronous active-active replication. So any information that is on node 1, it is going to be on node 2. The same exact logic is used for L1 caching. This way, your write-back DRAM caching is replicated between your whole storage cluster, and then in case one of the node failure, you will be completely safe, and all the information that was cached will just stay available from the second node. And then, yeah, we have also L2 caching, which is using solid-state drives as the caching storage, where L1 caching is using random access memory. So L2 caching can also be configured in write-back and write-through. It works the same exact way as L1 caching does, but uses solid-state drives. This way you can put a bigger caching volume. You can even have, for example, SSDs equal to your primary or hot data set. This way, basically, every single virtual machine will work directly with SSDs, and in very rare cases, when they would need access to the data that is not hot, they will go lower for spindle drives, if you are using a hybrid architecture, if you are using a full flash architecture, L2 caching is not going to be really that useful for you because your whole storage is made of SSDs. So, snapshots and automated storage tiering. Now this is the other set of features that we have available in StarWind Virtual SAN, and it is available for our log-structured file system device. This log-structured file system device has completely different logic compared to regular image file that we've been talking about previously, and this device was especially designed for slow to medium performance or RPM spindle drives that are preferably configured in RAID 550, 660, so basically parity RAID, and I'll right now explain you why. So this log structured file system, what it does is it takes small random writes, for example 4K write block that RAID 5 has real troubles working with, as it provides you with extremely slow performance on those patterns, as well as RAID 6, RAID 50 and 60. And what log structured file system would do for you is it would collect those 4K random writes and convert them into one huge sequential block and write it to the storage. This way we boost performance for RAID 5, 50, 6 and 60, and as it is a thin provision device and a log structured file system, it also has snapshot support, and it also has storage tiering available to it in a matter of, so you will have your primary data sitting on LSFS, and then your secondary data will be replicated to somewhere else. And yeah, so pretty much this is how it works. Now on the next slide we will actually talk about LSFS a little bit more. So deduplication and compression, this is something that you also have within that device. It does have inline deduplication, and how exactly does that work? So imagine you have I don't know, 10, 15, 100 virtual machines that have Windows OS installed, or basically that are doing pretty much the same thing. And what LSFS will do is, when there will come a lot of identical writes to it, instead of writing all of them and then doing traditional deduplication, so it will write all them, then in the deduplication procedure, it will look through all the blocks, see that there are 5 identical blocks, will remove all of them and have only one block instead of 5. How we do it with the LSFS is, if we see that there are 5 identical blocks coming in to our device, instead of writing all five of them, we will write one and then provide for links to this one block to everybody else who had sent the same write request to the storage. So this is how inline deduplication works with our device. And then another feature, which also includes log structured file system, is asynchronous replication. Asynchronous asynchronous replication was designed for disaster recovery. Exactly what we were talking previously about. So on your main site, you will have your highly available device that is providing your main production cluster with the storage, and it's all good. You're happy, you're redundant inside your facility, and everything is great. And then what you do is we set up replication from your main facility to the cloud or to your another facility, so basically somewhere else, in order to protect you from any natural disaster or anything that could potentially happen to your main facility, and as a result you would lose all your data. So this is how asynchronous replication works. Then on this slide, actually, I a little bit did run through. I mean, I've explained you how StarWind log structured file system works with its block conversion a bit before this slide, but here you can see this being explained on the picture that might kind of make it easier to understand, as you have three parts of the puzzles that are kind of random and that wouldn't fit into each other, and then eventually you have one big chunk like of these puzzles convert into something that looks nice. This is pretty much what LSFS does by converting your small random writes to big sequential writes. And then scale up and scale out, this is another feature we've already discussed. And the last and my favorite is support. As I am the head of support department, I really do like this part. So the best thing that I personally think about our solution is the way we support it. So let me provide you like a set of things that are done from our end in order to make the customer happy, and then I'll tell you how customer would see it from his side. So as soon as we get somebody to purchase our solution, we have the hardware assembled, configured, and tested before a customer gets the system, and then when he gets the system, it is fully pre-configured, pre-tested, and everything is good about it. So when you are a customer and you see like boxes arrive from StarWind, what you really need to do is basically unbox it, plug in the networking, plug in the power, and you have your system ready to go and to serve your production with the data. Then the other cool part about support of these of our solutions is that we do support the whole solution. This way we eliminate any any finger pointing from vendor to vendor or any issues at all that people are facing with support while building these solutions themselves, or while having different vendors in their solutions, just because this is how it works. So what we do is we will support the whole thing. So we will support the hardware, we will support the software, and we will support we will support the OS, we will support everything at all, staying a single point of contact for the customer. So in case any of our customers that has our appliance solution will face any issue at all, any question, anything, he will always have one number to call or one email to write, and this person he will call or write to will always provide him with an answer and solution to his problem. And this is what I think is very cool, and this is what I think makes our solution extremely good on the market, especially because we are SMB aimed, and people in people having small business would usually not have a lot of money and time to understand how everything works, to maintain the system, to configure it, and put some effort and time into building a solution where we will do it for the customer. We will basically maintain it, as will help with any questions and any configurations. It will come fully pre-configured, and you will have support for every single part of that system. And yeah, so that's pretty much it. This was, I think, pretty quick overview of our storage appliance product, and in case you have any questions, I would really love to hear them.
Great. Thank you so much. Please submit your questions for Owen, and we'll have him answer them. First we have, can I use SA host to run my DC and ask you guys to pre-configure it for me?
Yes, you 100% can do that, and we will have your domain controller configured. You like it, you'll have an engineer call you and ask questions about like the IP address configurations and so on and so on, and then as soon as he gets all the required information for doing that config, he'll go ahead and configure that for you.
Okay, thank you so much. Here's another question. What if neither of the presented models fit my needs? Can I customize the configuration?
That is a very good question, as we are extremely flexible in our models and in our builds, and we do realize that everybody can have different needs, storage-wise, performance-wise, and so on. We have tried to cover most scenarios within our mobile lineup, although in case your workload and your needs are different from what we have pre-built, we will definitely make sure to understand and know what exact performance requirements do you have, as well as the capacity, and then make sure to tailor our solution and hardware configuration to fit your needs.
Okay, thank you so much. We have another question. It's about async replication, and the question is the async replication controllable, or when is it performed?
It is controllable. You have a snapshot scheduler through which you specify how often snapshots will go from your main side to your disaster recovery side, and how many snapshots would you like to keep on the disaster recovery side. So how many basically recovery points do you want to have, and then after reaching that amount, for example, if you set 5, when there is going to be made 6th snapshot, the previous one will be deleted.
Great, thank you so much. Here's another one that they're asking about how secure the data is, you know, like from hackers and cyber criminals and breaches and stuff.
So there are actually a couple of ways to make your data secure in our solution. So the first way, the easiest I would say, is to basically get self-encrypted drives, but they are kind of expensive comparing to usual ones. So there's also another way that would require some configuring, but again, not from you, but we will do it for you. You can basically use BitLocker and have all your data on the drives encrypted. As StarWind is a Windows native application, we do support pretty much all Windows, I don't know how to say it, features or functions that they do have for the storage.
Thank you. We still have a couple more. If you have a question, please feel free to submit your question now, and we'll get to as many as we can. And here's the next question. Does your support umbrella include OS support and additional software support like Veeam backup and replication?
That's a very good question. So our support umbrella does support the OS, and yeah, it does 100 support the OS, and we actually have Veeam backup and replication in another solution that is called Backup Appliance, and then we are also sister companies with Veeam. Therefore, we would definitely support Veeam and some other software that we are certified or familiar with, for example, like 5.9 or anything else that is Windows native and would count as an OS support.
Okay, thank you. Here we have a question about scale up and scale out, and it's how does scale up and scale out work with your solution, and what is the difference between them?
So I kind of, I guess, answered that question while the demo, but it works extremely easy. What you do is you basically, in case of a scale up, you basically add drives or JBOD to your existing setup, and what you do is in StarWind Management Console, you right click on a device that you want to extend, you press extend, enter amount of space you would like to extend it to, and it will extend. That's it. In case you're doing scale out, the procedure is pretty much the exact same, but instead of adding drives or JBODs to existing infrastructure, you just add in another node and then extend your storage.
Okay, very good. And here's another one. With your multi-protocol feature, what protocols do you actually support?
So we do support iSCSI, we do support SMB, we do support NFS, we support ISER and NVMef.
Okay, let's see. On the StarWind vSAN diagram, you had switches. Do you need them for SA deployment?
We do not need switches for the for the storage appliance deployment at all, but in case you would like to go more than a 2-node storage appliance, you would have them, and you might have them in case your existing production does not have enough network channels available for the integration, basically. So in case your existing infrastructure does not have 2 iSCSI channels available on both hosts, so that you can get the storage from our boxes via iSCSI, for example, you would need to add switch.
Okay, thank you so much. You know, that's all the questions that we have. We got through all of them, which is terrific. Before I close out the event, did you want to add anything?
Yes, sure. I wanted to thank everybody for coming to this webinar, for listening to me and what I'm talking about for so long. I really appreciate the time spent, and I hope that the information that you've heard today will be useful for you in future. And then once again, thank you very much. My name is Always Boyce. I'm with StarWind. In case you will need any additional information about us, you have my email on your screen, you have our website on the screen, and you have our address. So case you have any questions, you know how to find us. Thank you very much once again for coming to the event.
Well, Olis, I want to thank you, too, for your great presentation and Q&A session today. We really appreciate you taking time to share all this information with us. And I'd also like to thank the audience for attending this webcast sponsored by StarWind and presented by Redmond Magazine. Thanks again, everyone, and enjoy the rest of your day.
Ladies and gentlemen, that concludes today's webinar. You may now disconnect.